All right. Hello, everyone, and thank you for joining us for this Frends training session webinar. My name is Asmo Urpilainen here from HiQ Finland, and I'm the Director of Product Development for the Frends integration platform. And I will be doing the presentation and the training today. And just a brief recap of the actual agenda we're going to be going through today. First off, we're going to be starting with the kind of concepts and architecture of the Frends integration platform itself, and looking at a couple of PowerPoint slides basically, and we'll try and keep that to a 30-minute kind of a briefing, purely from a technical and functional point of view, before actually then moving on to the more concrete steps in Frends in practicality. So the first hour of the training webinar will mostly be spent on kind of trying to understand the core concepts and functionality in Frends. So partly by looking at the slides on a higher level, and then reflecting on that in the actual Frends user interface. And after the first 1 hour period, I think we'll have a short or a brief technical break of 5 minutes to give everyone time to get more coffee and set up for the next portion, and then spend the second hour going through some of the cases that we've prepared for you. So there's going to be a kind of two different developer journeys in that sense. So we're going to be taking a look at basically creating an example process in Frends for a more traditional backend integration, and then how to expose and create APIs with Frends and follow along on that path, and then finish off with basically taking a look at the administrative side of things, so governance, features management, and things like that, while also having a strong emphasis on monitoring features and functionalities that we're able to provide for you, our customers. But that's about it, the long and short of it, and let's jump right into the action here in the slide set. And just to of course mention here that I have a couple of colleagues here with me, and if you have any questions, there should be a chat enabled for all of your viewers, so you can actually if you find an interesting bit or something to ask about, just post it in the chat, and my colleagues will bring that up to me, and we might answer a few questions here or there, but as there's quite a lot of viewers here today, we probably won't have time to go through all of them. All right, but let's actually get right into the business itself. So we are actually now talking about well Frends obviously, but currently what Frends basically is an integration platform as a service that of course we're providing for our customers from our proprietary cloud from Microsoft Azure. And pretty much the thing that we are trying to do or trying to achieve for all of our customers can be split into kind of two different categories. So these categories are kind of front-facing or business-facing, as we kind of like to put it, or the kind of more traditional back-end-facing, where the difference is that we're kind of treating these two different concepts of having the kind of API platform ideology, where the main goal of that functionality is to provide users with a pipeline and developer experience to publish APIs to be utilized by, well, of course, internal systems, web applications, mobile apps, even B2B partners or peers, anything of that sort that has to do with basically publishing online interfaces using the functionality of Frends. And then the second portion of that is of course then the kind of integration backend, in that sense that we have those more traditional integration scenarios, such as application to application or data integration between two different data sources. And the key point or power that we're trying to leverage here is of course having kind of synergies between these two approaches, and it all kind of boils down to the kind of low-code mini-service ideology that we're trying to bring for our customers. And what that actually means in reality is that if we take a look at the kind of back end first, we've basically split up the core functionality of the more traditional integration scenarios into 3 different layers. So the first layer that we're going to be talking about is the kind of integration flow trigger layer. So whenever we have any sort of an integration pattern or scenario, we need to have some way of actually initializing that integration, and that boils down to the actual triggering mechanism that we have in Frends, and of course in the demo later on, or in the developer journey, we're going to be taking a really closer look on each one of the different trigger types and functionalities that we are able to provide. But after we now have specified and we have the capability of actually starting our integration pattern or scenario via various different means, or combining one or more of these means together, we have what we're calling kind of the integration runtime layer. So this is the layer that we kind of build the different integration patterns or architectures in that sense, and where we do the visual definition of the integration itself, and where we actually implement any business logic or rules that we might want to have within our integration itself. And the important bit to note here, that this is actually exactly the same layer and exactly the same terminology and functionality that we have on the API publishing side of things that we're going to be taking a look at in the next slide. But the orchestrator layer is basically built up of components that we are calling low-code mini-services or tasks, where the ideology now is that those are the kind of concrete steps that we should be performing in each of our different integration scenarios or patterns to then actually achieve the desired end result. And this means that the low-code mini-services or tasks are the components that we could use to, for example, now wrap legacy application functionality behind this sort of an abstraction layer, or connect towards, let's say, an SQL database to retrieve raw data from that database, or even in many cases nowadays, wrap mini-services that customer, or microservices that the customer has created, or any other type of services that they might have just floating around, and kind of bring those into the fold, so to speak, so that then we'll be able to have that integration catalog that tells us which is installed where and how should each of these things be consumed, and of course then combining all of this together to then achieve a certain type of an integration pattern, for example, between 2 different applications, that one of them might be a cloud application and one of them might be a legacy application. The second portion of that, of course, is then the API or the front end side of things, like as we like to put it. And you can also, of course, immediately notice here that the key point is that we are keeping the same low-code mini-services layer here, both on the back end and the front end side of things. So this means that if we create some sort of functionality or component in a, let's say, traditional application to application integration scenario, or even an ETL scenario, we can utilize that same component seamlessly in any APIs that we would be creating or would like to publish. And the synergy and compatibility between these 2 worlds is what makes us kind of a hybrid integration platform, in that sense that you're able to bring the kind of strengths of both sides to the same platform at the same time. And talking a little bit more about the actual front end stuff, so publishing the APIs and going down that API or service route, we similarly split the functionality between two different or 3 different layers. The low-code mini-services one being exactly the same we just discussed, but the additional layers on top of that are then the API engine layer, where just as we would do with the traditional integration scenario, so for example, the backend systems here that we just took a look at, we are now using the API engine layer to orchestrate what the actual API should be doing. So what are the data sources, what are the functionalities that the APIs should gather together to then fulfill the need of the actual published API for the consumer. And of course, this can be utilized to create orchestration between different systems or composite different APIs from whatever system might be offering their own native APIs to then have a more coherent pattern or a coherent layer that we can then expose to the actual API consumers, and kind of takes care of the development portion of that. So acts as the bridge in that sense between the technical implementation that then is wrapping the actual systems data and all of that, and then the kind of logical layer that then is actually publishing and having that API available for consumption. And the final layer, of course, is then the API gateway layer, as we like to call it, where the main concern is, of course, now securing our APIs and managing the APIs that we are publishing for the outside world. So now we can, of course, understand who gets to access what functionality in what form or what sort of data sets should each consumer of the API be able to access. And of course, have then the audit trail monitoring capabilities built in there, so you can then track the user's path or any sort of a given identity's path through the layers and into the actual system or kind of end result of the API itself. And these two layers, basically, now the backend side of things and the front end side of things, are what constitutes the main Frends use cases that we're building for our customers. And ideology now, of course, is that what we are doing to actually provide this capability for our customers is have a little bit of a different architecture than what people are probably used to. So we are talking about this sort of a distributed architecture. So you can remember from the couple of previous slides, we had the low-code mini-services layer there appear on the bottom, whose job was to provide the technical connectivity and capability of connecting to actual systems data, the kind of source and targets of all integration scenarios, be they APIs or the more traditional scenarios. And the main point of the distributed architecture is that we are providing a single, what we are calling a control plane. So basically a website that we are calling the tenant for each of our customers from the cloud, or of course on-premise. Some of our customers have the control plane even installed in an on-premise environment, but the more common use case definitely is in the cloud format. And the ideology behind here is that the control plane is where we actually interact with the integration environment and do the development, do the monitoring, do anything that basically humans would like to do within the integration landscape or the bigger picture of the implementation. But the control plane doesn't actually implement any of the integrations themselves, but rather what we're doing is attaching agents, or in our terminology, agents, to this control plane. And the ideology behind the agent is that the agent is actually the one providing all of those three different layers of functionality and executing the integration runtime per se. So providing, for example, the abstraction layer to wrap the CRM functionality within an agent that could be installed in, let's say, an AWS environment. And when we could have another agent that's attached to the control plane that then would for example, be installed on the customer's own on-premise environment. And that agent would then be responsible for example, wrapping the data warehouse or the warehouse management system functionality behind the same low-code mini-services. And from the control plane, when we're actually then creating the integrations themselves or the APIs. So when we're looking at the different layering here, we're at the API engine layer, or then in the integration runtime layer, where we're actually creating the orchestration and defining the functionality. So that means that in that layer, we can then utilize the data functionality, anything of the systems that we have wrapped within this low-code mini-service architecture harmoniously. So we could then create an integration pattern for an application-to-application integration scenario, where some of the data might be coming from, let's say, the CRM in the cloud environment, and that data could be combined with some data coming from the data warehouse, and then it might actually end up in, let's say, an ERP that's then installed in a completely different cloud environment. So it might be a private cloud, or even, let's say, an Azure environment that has a private network set up for the customer. And the ideology behind here is, of course, to being able to bring those agents close to the capabilities and the data and the systems that need integrating, and having them kind of completely unreliant on the control plane. And the control plane is simply there to offer the users a way to interact with the environment from a single harmonious user interface. A couple of words maybe about the actual agent itself. So we talked a lot about the control plane in the previous slide there, where the ideology is to have the kind of user-based stuff happening there in the control plane, but the agent is actually consisting of the same layers like we talked about for the logic and the orchestration, or the implementing the integration pattern, but everything is then, of course, also built on top of the low-code mini services or tasks that we are talking about, and combining those different tasks and mini services is what creates the functionality for either the API or the traditional integration. And this means that the agent is actually the one who is now, for example, exposing an API, if that would be the case that we would want to do that. And that's the same functionality that we use to, for example, provide this sort of federated API gateway functionality. So if you want to publish different APIs from different locations or different clouds or servers, you're simply able to control that by saying, okay, this agent should now be exposing this sort of an API, or this agent should now be starting a scheduled triggered integration that's syncing data between the workforce management and the warehouse management system every 15 minutes. So the agent is actually responsible for providing all of the capability for the actual integration to happen, and it's loosely connected to the control planes or the user interface, meaning that even if there are network glitches or hitches there on the way, the agent is not relying on the control plane to actually be able to execute its functionality, but rather it's reporting back on a standard basis what has been happening with each integration or API, and then it's of course listening for new directions. So if we create an update or create a new solution, the agent is able to then download that from the centralized control plane that we're offering for the user. This would pretty much be the kind of standard kind of a technology stack / architecture that we're talking about and dealing with within Frends. And now if we actually jump over to the actual Frends platform, so start digging down in the nuts and bolts of the platform and trying to figure out how do all of the pieces that we see here fit into those architectural and functional slides that we just looked at. So the first thing to note here, of course, is the heavy reliance of the agent functionality, which is pervasive throughout the Frends control plane or the user interface. So this means that whenever we're looking at pretty much anything inside here in the control plane, we're always looking at things from the agent's point of view. So we always need to choose which agent are we gonna be kind of looking at things from their perspective when starting to navigate the user interface. So this means that in my case, in my sales demo environment here, what I have installed is 3 different logical agent groupings. So you can also use the agents for providing this sort of a multi-CSI capability of having the different systems appear in different places and then connecting those together through the agent architecture. But also the agents are commonly used or almost always used to provide this sort of a development or a DevOps type of a pipeline for the development practices, where we're able to take any agent that we have now installed somewhere. So we might have a cloud agent installed here for our testing purposes, or a development agent installed here on another cloud server, and we can take any of those agents or a grouping of agents and group them in these logical containers called environments. And the ideology behind here is now that the most common logical grouping is, of course, having development, test, and production environments. And here we can actually see that in each of these environments, we have a single agent available. And now we can, of course, direct each of those agents on doing different things or executing different versions of the same integration or API. And this agent navigation per se is key to understanding how to efficiently jump here between different solutions in Frends. So if we take a look at the kind of standardized process integration catalog per se, that gives us the view of what sort of solutions we have available here in Frends. You can see that now we are looking at the development environment, and there's actually things are executing here as we speak in real time. But we're also able to now, for example, just jump into the test environment. And this is now all of these solutions are, of course, executing on a completely different databases, even though the functionality of the integration is the same. And of course, all of them, they have their own monitoring data. And the key point to note here is that the versions and, of course, the set of the different integrations we have available can shift radically between the different agents. So, for example, in my production environment, I only have two processes that I don't have in my testing environment. But then, of course, I have all of those combined in my development environment, because I have now enforced a rule set for the developer that they cannot make changes to any environment except the development environment. And we always have to follow this pattern where we would use the development agent and the development environment to do our development work, obviously, but also at the same time disallow people from making changes in the test or production environment, so that then they're always forced to kind of go through the quality gate pipeline of creating that solution in development, deploying it to test, and then deploying it to production. And we're going to be taking a look at the deployment in a more coherent fashion a little bit later on. But the environment and agent distinction is really important in all cases. And of course, like we talked about, that applies to the kind of standard integration scenarios, APIs. So we're always looking at the integration from a single agent's point of view, but that also applies to the low-code mini-services that we would be creating to wrap, let's say, the system's functionality in let's say, an ERP's functionality. And that's the same thing that we are having the same ideology that different environments can have different versions and different monitoring data for different solutions in each of the different agent environments. And of course, the same thing applies on the API side of things, where we might have our nice little AdventureWorks API here available. And of course, now we could take a look at that and see that the AdventureWorks API is actually of a different version in the development environment and in the production environment. One key addition to the environment thinking and the agent thinking here is that now we are in a stage where if we have different solutions in different agents and different environments running, those solutions usually require some sort of configuration to be able to actually execute the desired functionality. And this configuration usually could include things like database connection strings or API keys to third-party services, usernames, passwords, data mapping documents if we want to map different values for, let's say, different data sets to other values. So anything that we might want to have kind of as a separate entity that's not directly reliant on any integration, we now have the environment variables ideology and view behind that, where basically we are able to create for each environment a static variable, which now contains, for example, for my AdventureWorks database, it contains my connection string value that, of course, now I can set a different connection string dynamically depending on which agent or which environment I'm running that particular integration in. So this is here obviously to enable things like if we want to enforce a development pipeline where you always have to do development in the development environment and then deploy things to, for example, testing environment, you of course would like to perhaps do your development locally on your own laptop, and then you would have a connection string, for example, for a local database and do the development against that in order to not disturb any sort of other production or testing databases. But once you deploy a solution to the testing environment, then of course you might want to have a different database available for you there and automatically switch between these sort of configurable values, and the environment variables are there to provide just that. So the functionality of being able to automatically choose different values rather than having to manage all of that by hand. And finally here, I think the environment's view itself that we kind of also already looked at a little bit is here now to, of course, then manage the agents themselves. So there's, of course, we have guides on how to create or add new agents and do the configuration and install a new agent to the environment, or add an additional environment that might be called something. It might be called a production DMZ that sits in its own network segment. So we could use the environment's view to basically see the structure that we have set up, and of course add, decrease different sorts of points in each of the agent environments, and have, of course, a heartbeat functionality there as well to see that whether or not everything is actually up and running or not. Perfect. That's pretty much the gap between the agent architecture or the distributed architecture and the different kind of views and viewpoints we can take in Frends. And I think the next step that we're going to be taking a look at here is going to be the kind of basic development functionality that we are basing pretty much all of the development in Frends on top of. So going through a really simple case and the kind of different pieces that make up the integration as a whole, or the integration scenario as a whole. So that might be an API, or it might be just a simple FTP file, the file download or a file upload. So it doesn't matter what the kind of integration scenario or case is. We're always using the same visual interactive developer experience or interface in that sense to provide you with the tools to then perform and create the different functionalities needed by each integration. And kind of like what we looked at here in our previous slides, where we have, for example, now the two different layers. Those two different layers are now, of course, corresponding in the user interface as processes and sub-processes from our perspective. But whenever you go to create any sort of an integration or a component within Frends, you pretty much have three standardized pieces of the puzzle that you need to put together at minimum. So in actual production usage cases, there's usually tens or even hundreds of different steps and different sorts of functionality combined. But the bare bones minimum of what any or each integration or API solution should have is some form of a trigger. So we looked at the different sorts of trigger flows here. So we need to do some sort of configuration on how do we actually want to start our integration. And of course, here is where we kind of decide what sort of an integration this or a pattern of integration we're going to be following. So if we're, of course, going to be creating an API, then we might be utilizing what we're so calling having an API trigger. So basically determining and getting a ready configured, someone has pre-configured for us an endpoint. And of course, we're going to be taking a look at that later on in the API section. Or we could have, let's say, a schedule-based integration where we might want to actually specify that rather than the integration being started manually, we actually want this particular integration that we're about to create to be executed, let's say, every 2 hours between 8 a.m. and let's say 8 p.m. And this schedule should be active on these particular months of the year. So let's select all months except December, because we don't want to have something happen in December. And even in addition, let's say that this particular schedule should actually only be run between 8 a.m. and 8 p.m. every 2 hours on the first and last Wednesday of the selected months, except on the 31st of next week, since that's going to be our UAT day, or it's going to be a banking holiday. Or you could even import calendar dates here directly if you have a list of things that you wouldn't want to run this particular schedule in at that particular point of time. But the schedule is, of course, only one of the different types of triggers that we can provide for our integration scenario. So, of course, we could have a manual trigger where we can now specify different values for the user to actually start the integration manually from the integration catalog list. Or we could have a legacy HTTP trigger where we might want to expose an endpoint that we can communicate with a system using, let's say, XML over HTTP, or just simple key value pairs, or anything of the kind of more traditional HTTP web-based protocols. Or definitely we could do something like saying that rather than it being a schedule, we actually want to look at a file. So we might specify a specific, let's say, SFTP, FTP, or a shared file drive somewhere in the cloud, that if a file appears in our specified directory and matches our given file mask, that would be then the kind of first arrow to then start the integration flow itself. And any sort of a queue would also be all right. So AMQP, QP queues, JMS queues, the Azure Service Bus queue, etc., etc. But by far the most interesting one would be the conditional trigger. So the conditional trigger is actually now a new feature in Frends 5.1, and the conditional trigger is here to provide us with a dynamic way of looking at some sort of a data set in, let's say, an API, or let's say a system or a database, and actually being able to build the logic within that conditional trigger to determine when should we actually start this integration based on other factors than what we can provide here directly within Frends. So this means that we're going to be, of course, taking a look at this in a little bit more detail later on. But as an example here, I could have a trigger where I've configured in the conditional trigger that actually I'm calling a public API to basically select and poll this API that's now looking at a specific city. I can give the configuration for that conditional flow, and that flow is actually getting the temperature data from a public weather data API. And I've created logic here that whenever the temperature of, for example, now in this case Helsinki goes above 278.15, I think that's probably in Fahrenheit. So for those of you who don't be alarmed, we're not going to be baking alive, or actually that might be in Kelvins even. But the ideology behind here is that now we are able to create this sort of a dynamic link between some sort of a third-party API system or data and determine which should be those scenarios that we now want to actually start the integration flow from. So the trigger is a key point in any integration that we would be creating. And of course, in addition to the trigger, we need to have some sort of functionality. And the way that we build any functionality, or pretty much any and all functionality within Frends, is using what we are calling tasks, or the low-code mini-services, where we basically specify that something should happen now in this integration scenario. And of course, depending on the integration pattern that we're deciding to utilize at this point, that functionality could change radically from solution to solution. So all of this is standardized and generalized in a sense that everything is compatible with everything else. But a neat example of this might be just to, let's say, download files via FTP. And now we've specified that that's what we would like to happen. So we would like to trigger our integration using the schedule we just created. And the first thing that should happen in this integration should be to download files via FTP. And now we need to actually provide the configuration for that particular step in order to tell it how to perform that functionality that we want it to perform. And here we're of course relying heavily on the library of these different steps and tests and tasks that of course we're providing for the customers out of the box to, for example, read files, call web services, query databases, transform data between different formats, merge data, split data, anything that you might kind of think of as a step required by the integration flow to be able to complete its functionality, we would define as a task or as a step in the integration flow itself. And this is the basic ideology now behind any type of an integration, be it an API or a traditional integration, that we determine the trigger point, we determine the combination of the different steps or tasks within that integration, and of course the logic in which they should be or executed. So you might have things like you might want to create, let's say, parallelism inside Frends. So saying that these two actually steps should be executed after the first one at the same time, but only move forward when both of them are successfully done. Or you might want to add some sort of decisions here where you might have a different sort of an outcome based on some sort of a factor or a value or a result of a step that we are doing to then actually now create the required business logic by combining these simple steps and tasks together. Of course, there's a whole bunch of other functionality and stuff here as well, but that's where we're going to be saving that for later when we're going to be going through the concrete cases, which gives a better idea on what each of these steps or shapes actually does. But the standard model that we utilize across everything is the combination of the trigger, so the first point in the architecture, and of course the trigger is obviously the actual published API in the API scenarios, and combining that with the orchestration layer, so in which order should we do what, and then doing the configuration of the tasks, of the low-code tasks within each step to then provide the actual concrete functionality. So this would be kind of a brief introduction now on the kind of core concepts behind creating the actual integrations themselves. And now, of course, we would like to use that information to then create all sorts of solutions. So in my case here, if we take a look at the main integration catalog, for example, and have our development environment available here, now that we've created some sort of an integration, so let's take our FTP file upload and download here as an example. I've done my configuration on specifying where should I actually get a file via FTP from what server using what sort of passwords and usernames and all of that. I've also specified that there are two different ways to start this integration. One would be with every 30 seconds, and one would be with a manual user-given input from the user interface right here. But the important bit to realize here as well is to have that built-in version control that we're providing for our users. So that means that once we've now gone through the steps of specifying and creating our integration flow, we've created our configuration for our different steps. We're happy with how our integration looks like, and we click Save Changes. So we want to now either create a new integration altogether or do a change to an existing one. We are now actually utilizing the built-in version control and governance features within Frends to actually be able to have that version update and have that older version available for us for later usage or whatever might be our case in that case. So you just saw that, for example, the version number now updated from 1.1.5 to 1.1.6 when I changed something in that particular integration scenario context. And of course, now that when we created our change in our integration configuration there, we are now able to take that in different versions, so the new version of our file upload and download, and push that to any other agent that we have specified in the grand context of the environment within Frends. So if you remember, we looked at the development, test, and production environments. We are now able to utilize that automatic version control information and that automatic versioning of different integration solutions to take any sort of a solution or a set of solutions or integration flows and simply say that actually what we want to do is we want to deploy this integration flow to the cloud agent that we... there was a question on the chat that read, do you have plans to have built-in support for webhooks in Frends? And the answer is yes, definitely. Those the conditional trigger that we covered there earlier is the first iteration of triggers that we're planning to add, and that answers a lot of questions. But for example, for webhooks or even WebSockets and things of that nature, there needs to be a custom trigger or an implementation that we are providing from the platform side of things, which is definitely on the roadmap there to answer that question briefly. But getting back to the version control here briefly, so the good thing here is that now that if we think about the architecture from a bigger perspective, where we have our solutions, we have our mini services, we have our facade services wrapping different systems, we have our APIs, we are now able to obviously now see the differences between each change that we do, but also use that same information to say that actually this solution for the file upload and download, and in particular the version 1.1.5 is something that I want to now have execute on a different agent than I'm doing the development on, or this could be the cloud agent installed in AWS as an example. So now I can actually go ahead and click deploy and activate triggers, which now means that if we jump over to the cloud test environment, we can now see that previously we didn't have this demo FTP file download and upload integration flow at all, but now we have the version 1.1.5 available for us in the cloud test environment, and we can actually see that it's now executing for the first time with that specific configuration. And well, definitely it's well, there was an exception, but it's built like so because there are sometimes the free FTP server refuses us access, and so I think we're sending quite a lot of data back and forth from that. But this is now the kind of pipeline and the ideology that we now have our different solutions and different combinations of integration flows, which all have their own specific version numbering, and they all have their own specific version history, of course. Now we're able to kind of control what is actually being executed in where. So if I now actually looked at my cloud test or test environment and noticed that, I have my integration flow deployed to the test here, and it's in version 1.1.5, and actually there's something wrong with it, I could go ahead into the development environment and see that, okay, currently someone is doing changes to version 1.1.6, but I actually now don't want to do anything or mess up some other developers' work. What I should be doing now is actually switching back to that version which is now deployed in the test environment and convert my current iteration into that version, open that up, go inside here and do the change that I basically wanted to do. So it might be just as simple as adding some sort of extra documentation or tweaking a parameter in the directory or file name paths or the FTP server address in general. But I would now basically do my change, save my changes, and now based off of those changes, I'm automatically being provided a version 1.1.7, which of course now isn't terribly useful for me because I now don't know which version is actually progressing in this sort of a version control history per se. So that's why we're providing the users the option to actually control and manage that semantic versioning themselves, and only the last kind of build number version of the process is something that we are managing automatically via Frends. So this now means that now as a developer, what I should be doing is, for example, having my 2.0 version that I'm now doing my change in, and I'm now saving my change as the version 2.0, which means now I'm not messing up anyone else's current work, and I would actually save that as the new 2.0, 2.0.8 version, and actually take that and deploy that 2.0.8 to the cloud test environment, replacing the previous 1.1.5 version of this integration solution. So now we kind of have full control over how do we want to manage what integration is actually executing in which environment, and even how are we combining data from different integration environments together to create the desired end result or the integration scenario that we want to take a look at. Maybe lastly here, before we have a short break, a couple of things about the integration catalog in general. So the integration catalog is here for two main purposes. So the first purpose is, of course, to provide developers and operators a way to either interact with the source code per se, so the current configuration of how this particular integration version of this particular integration is being configured, what information is it actually using to provide this functionality and capability, and second, provide operators or administrators a way to move and see the monitoring data that we'll be taking a look at a little bit later on what does all the monitoring functionality entail. But the key point here is that now we have both the kind of developer's perspective and the operator's perspective kind of smooshed into one view. And of course, now the ideology is that then if I'm an operator or a developer, I might be interested in different things. So now I would actually go ahead and select those kind of values or data for each integration flow that I myself would be interested in personally. So this actually means that now if we have a case that let's say that I'm an architect or I'm an operator, and I know that there's something wrong with, let's say, my SQL queries, and I wanna take a look at all of my SQL queries and see what's happening in there. I now have the option of course navigating the catalog via various different approaches. So one of the approaches might be the example I just gave you, where we might now go ahead and say that, okay, I actually want to see all integrations which are using or connecting to an SQL server, and then I'm of course automatically provided the list that these integrations are now utilizing an SQL connection for in some form or way or fashion. And or I might be interested in saying that actually I'm not interested in that. I actually want to see that show me all integrations which have been scheduled to run every 20 minutes or every 30 seconds, or which are triggered by a web form in our web shop. Or it might be something that we are hooking up to a dynamic trigger saying that show me everything which is starting based on a change in another system. So you have all of these different approaches to now look at the integration catalog to get the information that you need for your particular case. So it might be an audit trail related question or an operator related question where the operator simply wants to go in here and see what has gone wrong in the last 24 hours and see that, okay, I had actually 4 different problems here in the last 24 hour period here, and I might actually want to now start fixing those. Or it might just be the developer grouping things up so that then they can have a better view on what they're currently working at and where those things are being deployed at any given moment. All right, I think we've covered almost half of the kind of general things here. So this might be a really good time to have a short technical break and go get some coffee or visit the toilet, answer a couple of work emails if you're up for it. And I think we'll be continuing in, let's say, at exactly 1 o'clock finish time, of course. And during the second hour now, we still have a couple of things to go through here from kind of a general concepts-based perspective. And then the ideology is to spend the rest of the hour actually digging down deep into the couple of different scenarios that we have here for our basic integration scenarios, and then of course the API scenarios as well, leaving us some time from the end to actually then look at the monitoring and the governance stuff as the last bit in the webinar. But thank you everyone so much for so far. So we're going to have a short break and be back in 7 minutes exactly. All right, welcome back everyone, and I had to go get a glass of water to keep my voice going for the second hour here. Perfect. All right, so let's continue on where we actually left off. So the only things to cover for the second hour here are now the actual configuration and development procedure. So how do you usually go about creating an entirely new solution from scratch? And we have a couple of different scenarios here for the more traditional integration from an application to application or a file transfer perspective, and then of course the API scenario as well. And then to go through the monitoring and governance features like we discussed there earlier a little bit in the introduction. But maybe a small recap of the previous hour. So what we covered in the first hour of the presentation was the basic ideology of having these 2 different types of approaches for the standard integration and then of course the API side of things, but having them all rely on the same sort of visual low-code approach where we can now utilize components harmoniously between any sort of an API or any sort of a more traditional integration scenario. So having that common ground between the two is the key factor here. And we covered a little bit about how the traditional or any integration, be it an API or a traditional integration, is built, from the triggering of the integration by creating the logic and the combination of different steps to achieve our desired end result of the integration, while also taking a look at the agent distributed architecture, where we're able to take the agents and bring them close to the systems and to the places that we require the integration capability in to create these sort of hybrid scenarios for the integrations. And how do we actually now navigate between each of the environments and manage, for example, the integration catalog and the different solution versions in each of those specific environments. One thing before we move along, so and also I almost forgot, and also we covered the environment variables ideology, where we're able to now store in a harmonious single view basically the configuration data that the integrations we create require in different environments to be able to execute successfully. So, all right, if we get started on the actual API development side of things, so basically start from scratch in that sense that we want to actually now create an API out of thin air. So the first thing to do is we are basing all of the API development on the Open API or more commonly known Swagger definition, where the idea now is that you would first define the API, so basically define the contract for your API you wish to actually implement within Frends. And this would now be the second layer in the front-end picture here. So we would be in the API engine layer, so to speak, where we're now creating the framework for our API that we actually want to publish. And we won't go into too much detail on the Open API or Swagger specification here, since that's fairly standardized. There are plenty of good guides online on how to create a Swagger compliant definition. But the key point here is that we are basing basically the whole development and API lifecycle management on the Swagger definition. So this means that in the Swagger definition, we have things like the different sorts of message types and the schemas for the data that we're returning specified. We have all of the different API endpoints that we want to expose from this particular API defined. We even have, for example, the security definitions here defined. So if we want to, for example, apply an OpenID Connect OAuth 2 compatible authentication then on our API gateway layer, we also specify that in the Swagger definition. So the Swagger definition is the heart of the API, which expands both into the actual API gateway layer and the low-code mini-services layer. So it's kind of a middle-out approach in that perspective, and we use that as the kind of basic building block. So all API development paths start from the Swagger definition. And if we now imagine that we have our nice little Swagger definition finished here, where we first have defined that this is the sort of an API that we actually want to expose, we then get into a view that's the API's view. And the API's view here means that it's similar to the integration catalog. Hello, all right. So just a quick break here. There was a question on the chat saying that for new integration developers, what are the basic questions or basic requirements you should basically ask to get started in the development? I think that was a I'm sorry if I butchered the question there, but I think the question is that what sort of requirements you should have as a developer in order to get started with Frends. And I'd say that let's cover that topic after we go through a couple of the scenarios, since the scenarios give you an idea of what the configuration and what the concrete development work actually is. And through that, we can gain a pretty good understanding of what are the sorts of technical understanding requirements or knowledge levels that we require. Because apart from that, everything else within Frends should be fairly intuitive and of course would require a browse through the documentation or the help of a question asked every now and then. But the most crucial part is some of the technical understanding that you would then require in the actual development work. That's of course going to be up next in the API pipeline as well. But all right, getting back to the APIs here a little bit. So the key point is that now once we have our Swagger or Open API specification available, that gets created as its own API here on the API views. And similarly here, the exact same thing applies, that we can now have different versions of different APIs deployed to different types of agents in different locations or settings in that sense. But the important bit here is that now actually, if I go ahead into an API, and actually I need to cheat here a little bit and copy the SQL query here, and let's remove our API linking there. So let's remove the backend from our API and actually delete that as well. So now we're basically going back to a situation where we have an API where we haven't yet implemented an backend API functionality for the get product endpoint. So in the Swagger, when we do the definition for the API, where we have our product and our product get product ID, different endpoints for our API, each of those endpoints now gets automatically interpreted as the sort of Frends API endpoints here in the API's view. So this means that now, as an example, I have the product ID to find a product by ID endpoint that's already been implemented, and I can see that that's actually linking now to an orchestrating backend process here. So that would be the concrete configuration for the backend of that particular API we want to publish. So here we're actually creating the linking between the API engine and then the low-code mini-service layer to further have that middle-out approach present there in the development pipeline. And that also means now that I could have an API, and this would be the case when I'm starting from scratch and I don't have anything implemented. I'm getting inside each endpoint this button to now create a basically new link between the low-code mini-services layer and then the actual API itself. And once I actually go in there and click that button, I'm getting a similar view as I would in any normal API scenario or any other integration scenario, except now most of the information for me has actually been interpreted from the Open API Swagger specification, and I'm not now allowed to, for example, configure the URL from which I'm actually exposing the API. Or we might have specified in our Swagger here that the security definition or the security to access this particular API should actually be utilizing an API key. So that means that then that's interpreted to be set, so we can set the authorization to be API key. And of course now I'm not allowed to change this because we have the middle out approach where you first update the Swagger and the updates would then reflect onto each of the endpoint that we are utilizing here. And the benefit of doing it this way, so this middle out approach, is that now that we basically have a template where we know that we have a certain type of an incoming request that might have some sort of incoming parameters for us. And we are now expected to utilize the different combination of the Frends tasks and the functionality that we provide in the editor to reach our desired end result of the API. And of course, the desired end result of the API is something that we would then define in the Swagger editor, in the development and the API design phase. So in this case, we are now expected to return an array of product ID and product name information that then now we would know exists in a database somewhere. So this means that now as a developer, I know that this is what I should be returning. This is what I'm getting in. It's up to me now to implement the missing link, so the backend or the functionality behind the API. And now we're getting into the low-code configuration bit of Frends. So just as we kind of took a little bit of a glimpse earlier there on the file transfer side of things, we now know that, okay, if my scenario is to get the product list data in this format out of some sort of a data warehouse or system or whatever the scenario might be, I first need to know that, all right, so the system I can get the data out would be an SQL server. So I would go ahead and have my first task here available. I would name my first task here saying that, okay, that might be called, or this step might be called get product list from SQL. Let's call it SQL database to be exact. I would then go ahead and search through the different connectors or the tasks we are providing and see if, all right, if there's a case or there's a ready-made execute query task or component available for me. And of course, I can also jump into the source code of that particular connector here if I actually want to go ahead and have a look and see what's actually happening behind the scenes when I'm running this particular portion of the API or the process. But now what we are asked or required to do is provide the necessary configuration for this step to be executed so that then we are happy with the end result of this portion or this step of the integration process. And here we can see that for the execute query step here or task, we have two different tabs. So we have an input tab and an options tab. And the input tab is corresponding, of course, to the kind of incoming arrow. So what information do we need to give for this task in order for it to do what we want it to do? And we can see that, all right, so there's a query input we need to give. So this would be the standard SQL query itself. So the database query we want to execute on the SQL server to get our data out of the SQL server. So in our case, and I'm cheating a little bit, and I have the query here built from a copy paste. But pretty much this, in our case, for example, you're allowed to write any sort of a standard TSQL query there to get data or insert data, update data, anything you might think of would be the step now that we're executing. But in our case, we're just selecting product ID and product name. And of course, now we need to provide the connection string for this particular integration to be executed. So in this case, you could now, of course, give all of the information here and hard code the connection string as the example suggests here. But if you remember previously in the beginning of the demo or the webinar, we looked at the environment variables where we had our AdventureWorks database connection string now set for different solutions and different environments automatically. So now a good idea would be to actually access that same common environment variable rather than set that hard-coded value for the connection string. So in order to access any data or any functionality within Frends, we have what we're calling now the handlebars notation. So when you put double curly brackets anywhere in any configuration, even in the SQL query itself, you are now actually allowed to write standard .NET C# code within the configuration, or you could access, let's say, all of the different predetermined variables that we have for this step and in this context of the API to choose from the kind of predefined list. And of course, we can see that in the predefined list, we have something that's called the hashtag env, and that's linking now to the environment variables that we specify where we're actually storing our connection string. So rather than do the hard code, I'm going to refer to the environment variables page or the view, and now select that actually the AdventureWorks connection string is something that I want to be executing this against a database that I'm specifying for different agents in the environment variables view. And at this point, I would usually be pretty happy, but of course, now that I'm doing my configuration, I also want to make sure that is my configuration correct? So is it doing what I'm expecting it to do in this case? So I know that what I should be actually returning to the user from our query, so from our API, should look something like this. So I should have an array of JSON elements with the product ID and product name attributes. So I can actually now go ahead and create a new test. So basically a unit test based on the configuration I've now provided for my task step here. So now I can actually run my exact configuration here in the unit test format and see what would happen if this were to be executed properly. So I can actually run that test now. And a good thing to note here as well is that now actually what's happening there on the back end is that it's actually executing that on the agent we have specified for the development purposes. So it's not running that from the browser or the cloud, but it's actually transferring that execution to an agent of our choice and then getting the data back from there. So we can see that with this specific configuration, we are executing our SQL query, and we can see that the end result or the final query that we actually executed looked like this. We had our connection string, we had our command timeout, and our transaction isolation level set like so. And what we got back was a huge list of different products and product IDs. And we are now actually serializing this for you in a kind of a nice to read fashion, so it's a little bit clearer or simpler to understand what's happening there. But actually, I can now take a copy of the actual data and see that, okay, so this is now the concrete data that Frends is actually processing here. And a good thing to note here is that in our case, almost all of our steps and tasks that we are providing for you are automatically producing JSON as the de facto standard. So we get some information in, we do some sort of configuration, JSON comes out. And this would be the end result or the JSON that would come out of this SQL query in this case. So now this means that I can also affect, for example, the naming convention of the output JSON directly in the SQL query if I so choose. So if I wanted to now, for example, quickly tweak the product ID to be just ID, I could actually change that into the SQL query itself and execute the same test again, just as a demonstration. Now, rather than have the product ID be the element name, I just now have ID for that output JSON that then the task is actually pushing outward. But we don't actually need to do that, since now we know that this is the format of the data we actually need to return or push out. So actually the simplest thing to do here is to now realize that actually our data that we are querying from the database here and seeing that it's executing correctly so we can get the data out that we want is actually already in the correct format or in the same format that we would like. So if we take a copy of the actual data and we know that JSON is coming out, this format of the data that's coming out of the database query actually already matches that of our API directly. So now we can actually skip a step in the API development, which would now be mapping that data into the different fields or formats here within Frends. And just to give you guys an understanding or ideology on the ideology on how that would be done within Frends is we now use the same handlebars notation to actually specify that, okay, whenever the process goes to this element, we want to return something to the API consumer, which called our API from here. And what we actually want to do is always have an element or an attribute called product ID, and the value of the product ID element or the value of the attribute, that's actually something that we want to get from the result of the previous step. So the SQL query we run, so the result is basically something that we can see in here. And in the result, we can specify that, all right, actually, we want to dig down deep into the result and say that the product ID attributes value should be linked to the database queries product ID field. So something like this. And now, of course, this doesn't make much sense since the names of the attribute and the result are the same. But now this is the way that we would, for example, now be able to tweak and do sort of rich message enrichment scenarios or anything of the sort if we wanted to. So we might have a scenario now here that actually when we're returning things from the API, the product ID value should be actually padded with 3 zeros. So now we can actually just add the 3 zeros directly there. And now whenever the API is called, the output return value that we're returning to the consumer would be based on the value of the query, and additional 3 zeros would be added to the product ID number that we're giving out there. So now we're allowed to do all sorts of combinations and data mapping manipulation and anything of the sort. So we might even want to do things like saying that we know that the product ID is actually an integer, so we might actually just want to add 10,000 to that value to maybe reach the desired same effect there, or do some sort of a math calculation based on the product ID, or add some text to the product ID, or anything we can think of is something that we can now easily combine with the low-code approach to generate basically a reference from this particular point of configuration to some other configuration that we've given in a previous step that we've executed. But like we went through there earlier, we don't need to bother with that at all. And we can simply say that actually, let's not do this particular attribute-based mapping, but rather let's just take the whole result, so the whole output of the previous task. So then we just say that actually, never mind all of that. We just want to return everything that we get from the SQL query step as is. So the result we saw here, and that's something that now we actually want to put out through our API to the world. So now, of course, the thing is that in many different cases we might have scenarios where we actually would like to do, for example, filtering or ordering of the data or anything of the sort, and all of the data, because it's in a JSON format, is actually something that we could now apply Microsoft's link queue theories directly to. So we might actually want to execute an internal select or an order or a filter to the data result that we now got back from the database. There was a question saying that is an express version of a database usable with the agent? All right. So we didn't yet really cover the facts there on what are the kind of technical requirements of the agents, and we probably maybe don't have time to go that much into detail on that question. But definitely we'll get back to you, whoever asked that question offline. But definitely, yeah. Getting back to the API scenario here. So to recap here, what we've basically been doing a little bit. So we first defined our API using the OpenAPI specification. We then ended up with the API in our API catalog, and we noticed that actually now there wasn't an API backend or the orchestration layer defined for the get product endpoint. And when we went ahead and clicked the create new linked process button there, we now actually got to the view. If I didn't lose it, yeah, here we go. We got to the view where we had our initial incoming trigger specified already for us based on the Swagger that we initially built, and we implemented and tested out our SQL query against to get our desired data out of the database. And then what we did is actually just decided to return the whole data set from the SQL in JSON format as is. So pretty much now we would be done. So now what we can actually do is click create new process and activate it. So now our API is building on the background, and we can actually see that now we have our nice API AdventureWorks product API available here for consumption. And of course now it's only available for us in the development environment, but we could easily now deploy that API or that particular endpoint to any of the different agents we had covered there. So this means now that we could actually go into the Swagger UI or the open specification user interface, which is now based off the same Swagger specification we are always using. So the middle out approach also ensures that we are now also publishing the specification for our API in real time and in the kind of nice tester that we're providing you. So this can be considered as an API developers portal, but it's more intended for internal API developers or for developer testing purposes, and not something that as is would be exposed directly to the public as an open API, for example. But this pretty much means that we had specified that we want to have an API key as our API authentication method here in our Swagger. So we can actually go ahead and move to the API keys view in the administrator view and see that there are actually now a couple of different ways we can configure access to our API that the agent is now exposing or publishing. So the way that we've configured it now for this particular example, we're using an API key, and that means that I could now, for example, just generate a new API user here to be able to access my newly created API. So that would mean that I would create my new demo API user, and I would specify that I want this particular user to be able to access the API only in the development environment, and I want to apply an API rule set for this particular API key, saying that the API rule set for my demo API user I just created should be the allow access to AdventureWorks rule set. And the API rule set is now something we use to define which API operations in our published APIs, in which environments are something that we want to either allow access or deny access to. So let's imagine if I had a case I only wanted to allow access to the product endpoint and not the find product by ID endpoint. I would basically go in and create a new API rule set saying that this would be called allow access to adventure works API, and then say only product list. So this means that I would now specify the different API endpoints that I want to either allow or disallow access to. And in an easier, or the easiest way to go about this is simply to use the prediction here, saying that by default, everything is, of course, off limits. And in this case, I only want to allow the HTTP GET method. So this is now linking back to the GET method here in our API operation. And in our API, we want to have the AdventureWorks API, and I only want to allow access to the product API, but not the other get product by IP operation there, and select and say that, okay, this rule should now be applied to my demo API user here, and save changes, which would now mean that now my demo API user has actually two API rule sets applied. So I'm going to get rid of the first one and take my API key. And now I would be able to use my API key to actually authorize access to this API from the, of course, the tester framework here, but also, of course, in actuality, from the concrete API that's now being published in the cloud. So meaning that now that I've authorized myself with my API key, we could actually now go ahead and try our API out. And lo and behold, we got, of course, we can see that the request that we sent was sent to this sort of a URL, and there's all the sorts of curls available and all the good stuff. But pretty much now we can see that this is the response that we got back from our API call within Frends. And now, of course, we are now linking back to the actual execution of that API call, meaning that now that I've pressed the button, I've authorized myself using the API key I just provided, I can now actually jump in and see the different API executions here for my particular API endpoint in my development environment. So meaning that now the click we just did on the Swagger here is actually now this execution of the API, and we have all sorts of monitoring or relevant information available for us to now filter or find a particular API call or query that we've now received in the API view. And just to kind of demonstrate this here a little bit further, if we send in another request here quickly, so clips, there was another. Now we see that here instances have changed. So now we have our second API call here available, of course, for us as well with the demo API user as the authentication method. Other options or alternatives for authentication, of course, include kind of some legacy-based options like basic authentication, server certificate-based authentication, and things of that nature. But the main kind of other access point or the main other authentication method used would be the OpenID Connect and OAuth 2 token-based approach, where basically rather than store and create the different API keys and rule sets directly here in Frends, we are actually now linking to a third-party identity management system. So this might be your Office 360 account or your Azure Active Directory account, or in our case, the Auth0, which is a third-party authentication provider, or there are plenty of different identity service providers that are using the standard OAuth protocol and the OpenID protocol to enable authorization and authentication to all of their different services. So we would actually now register this sort of an OAuth application in Frends, specifying that we actually want to accept incoming API calls from these and these different identity providers. And then rather than have an API rule applied to an API key, we would create an API policy instead. So the policy is the OAuth or the token equivalent of an API rule, but now we would actually, rather than just store the user directly here in Frends, we're actually now grouping all of the different identities provided to us using the information that the identity provider is giving us. So these might be things like names, groups, type of subscription, anything that you might think of would be now something here that we might create this sort of a policy that now we can apply the API policy to either API endpoints, or just say that in order to access this API altogether, the user must exist inside the identity provider we have configured here. Perfect. Maybe a couple of words about the API development from a versioning perspective. So things to note here are that we are now, of course, versioning the actual Swagger document itself. So specifying that whenever we go in here and do a change, so we just change a simple letter or something like that, and we save changes, we can now keep track of that particular change in the API. Each of the API operations now are, of course, linking back to the underlying API backend system here, and each of those, of course, have their own version management separate from the APIs. And on top of that, now we're able to, with the middle out approach, detect kind of breaking changes, for example, for the API, because the ideology here is that now what we actually want to do is, if we're exposing our API and someone actually builds a software or a system on top of that, we need to ensure that we don't go ahead and change something that would break the existing API. So I can do this because I can break things by intention. So, but let's imagine that I go ahead in here and say that actually API key is not the way you are supposed to authenticate, and this is actually supposed to be open for anyone. So no authentication, no security protocols whatsoever. I go ahead and save changes, but that actually means that now I have my little warning here available for me, telling that actually, are you absolutely sure you want to do that change? Because that change would now affect the different API consumers, because you're now changing the contract for this and this and this different API operations. So it hasn't actually yet been updated to any of my API consumers. So if I go back to the actual API I have available here, I still have my API key authentication as an option here, and I have to use that. But now, if I want to, I can now manually say that, okay, I'm absolutely sure I need to do this change. This change I'm completely fine with it breaking my API. So then I could go ahead and click the update trigger button, which now would actually then propagate my actual change to the contract, and now change the exposed API's behavior to the outside world. But this now means that now we have the option of actually managing the different API functionalities and endpoints on the kind of higher API level. But now we're of course allowed to do all sorts of changes here in the middle that don't affect the pre-configured values that we're not allowed to change here. So now we have two different layers in which we can actually manage how the API actually performs here inside the Frends when being executed, and how the API behaves when we're actually exposing it outside through the gateway to some users in or API consumers in that scenario. All right, maybe that's enough for APIs for now, but to kind of follow along the same line here, now the next idea or the next step would be a fairly simple process here, where, for example, now what we would like to do is have not an API call, but a scheduled call like we looked at here earlier, and it's pretty much following exactly the same logic that we would be following or we would be followed in our API scenario, where we have our triggers, but of course now we configure our trigger here directly in the editor rather than it being predefined for us. And we configure the different steps to, of course, conform to our specific needs. But the important bit here and the interesting bit here is that now we can actually, for example, go ahead and take the step we use to get our data from the database as a JSON format, take that step and combine that with our existing, let's say, file download, which is now a scheduled process. So we can literally copy paste the step from an API we had and put that in the same integration flow. So what would actually happen now is that whenever this integration would be run, so that would mean every 30 seconds, it would first upload and download a file given using the given configuration we've provided for the specific task execution of this particular step. And the next step would then, of course, be the same product data query to the database we also used in our API. So this is here to kind of demonstrate now the ideology behind any type of an integration where we could actually go ahead and create something rather complicated. So something like, for example, a request. So this might be kind of an example process for a customer where we're actually now receiving kind of a warranty request and are doing all sorts of different automations and system updates here to then get the kind of final complete integration flow as a beginning. But the important point here is that now any of these steps that we're utilizing as a part of, let's say, this longer business process automation line of thinking are also compatible with everything that we have on the API side of things. And we utilize that exactly the same logic anywhere when we're building anything in Frends. So the final point here and the segue to, I'm looking at the clock here, and I've noticed I'm running a little bit late on the schedule, but we'll try to speed up here a little bit. But the final kind of an example here I wanted to go through was this sort of a dynamic integration flow example, where I've now first specified that I have my integration flow process, which actually isn't doing any of the normal task steps, since the purpose of this integration process is simply to demonstrate that now how we can trigger things based on changes in another system. So that means that the interesting thing here is the conditional trigger that we talked a little bit about earlier, where now I've actually specified that the conditional trigger is specified as a sub-process here. So I could go into the sub-process catalog and take a look at the conditional trigger I've specified here. And here we can actually see my conditions behavior. So I'm saying that I want this particular piece of integration code or integration flow to be executed every 60 seconds inside the start node, kind of hidden away in peace. And whenever I'm actually returning something outside to the main process here. So whenever I'm returning something out, we're actually starting the process and going through the different steps and functionalities in my integration process. Or when I'm returning something else, so I might returning, let's say, an empty result in many cases. So I might return a null result from this case. So this means that now actually I'm using a standard REST request step or task here within Frends to specify that we actually want to every 60 seconds create a request to this open weather map third-party service and query the specified city's weather data, and of course provide our API key for authentication, and then say that, all right, whenever we're getting that weather data back, so if we actually go ahead here and quickly run through a test here to see what sort of weather data we would be receiving, I'm doing a simple decision here now based on the response of the weather data that we are getting back, and I'm saying that from the result of the weather data query, if the temperature of the city we queried is larger than, or actually smaller than 278.15, then I actually want to start the process here. And for example, now this might be something that could be utilized in, for example, looking at alarms in different systems and specifying that if there's a specific chain of alarms or a specific chain of data that's streaming in, only when a certain combination appears together, then we want to actually trigger, let's say, an escalation process or anything of the sort. But the key difference here to the kind of older approach is now to be able to create these dependencies to different systems and not have to be actually kind of create that traditional polling mechanism where you end up with a huge amount of different executions or huge amount of different basically rows and functionalities of the processes that don't actually do much. Perfect. All right. So, but for the last 12 minutes here, I wanted to take a brief look at the monitoring side of things, and then a couple of words about the governance before we run out of time. So the monitoring in Frends and basically the way to access the data that we're now passing through in Frends has three different layers built into it. So the first layer is, of course, the highest level of possible, where we would be able to create a dashboard here saying that in this dashboard, what I'm actually interested in as Asmo Urpilainen, the user, is seeing, let's say, Adventure of Works database related calls for the past 3 days, and I want to see are they successful calls or are they failed calls in this example. And I could now see that, okay, so during the last 3 days we've actually made 105,000 SQL calls here, and now I would just rename my widget here to be SQL call and maybe successful. And I of course maybe would like to do that the same thing to, let's say, I'm interested in the AdventureWorks SQL calls again, for 7 days. But now I actually want to see the failed ones. So now I can actually monitor and see, and actually, wait, that's 7 days and the other one was 3. So let's change that to be 3. So now actually what I can do is I can now kind of stay on track there, seeing that, okay, so out of 105,000 SQL calls, 725 were not successful. And of course, I have access to the same information here in a more kind of a visualized manner than just rather a card, where I might say the same AdventureWorks API calls and show me successful for the last 3 days, and I can actually see that there's been no executions, and then 559 executions at that particular particular date and time there in the test environment, but let's actually take the development environment there. So now we can see that there's no calls here, but then suddenly we jump to approximately 5,000 calls every hour. And of course, then combining these different sorts of widgets together to create this sort of an instant view to see the things that interest you and see if basically everything is all right or if everything is not all right is the main point of view for this monitoring view. The second level is then from the integration catalog. So now we can actually approach this from two different angles. So I can either kind of take a systems angle, so a systems perspective, and go into the sub-process view and utilize that as the kind of way of connecting to the monitoring data that I'm interested in, or I can take the kind of integration flows perspective. So as an example, from the integration flows perspective, I can now select the environment I'm interested in and say that this particular API and its calls are what I'm interested in. So I would be able to jump in there and now, of course, have the date and time range. I can move through and see how many successful, failed, ongoing calls were executed at any given hour for this particular API. I have access to all kinds of information here. For example, what were the kind of incoming parameters for this API call? Were there errors? On what agent was it executed? Who started it? What was the authentication duration, etc., etc. But the important bit here is that now I can limit my kind of visible date and time range and say that, okay, actually, I'm interested in seeing all of the API calls where the product ID was a specific one. So only show me the APIs where we were managing or handling a specific product. And I might even actually tweak the date and time range to here to be a little bit more thinner. So okay, that maybe that's too much. So something like this. And now we can see that actually there's probably not that many calls here available for us. But now I would go in here and see that, okay, actually this particular execution of the API for this particular product ID and this username is something I need to now figure out what happened. So by clicking that row on the instance view, I now am able to get to the real-time monitoring view where I can now actually follow the execution of my API step by step and actually see that everything looks green. So this was the order that we executed this particular API call in. And the incoming information from the API consumer was that we identified their identity as the sales demo user with a client IP of this and this. This was the request address that they requested. They sent some sort of headers in the API call. And the first step that we did was actually doing the SQL query to get the specified product information out of the AdventureWorks database. And we can also still address the raw data here. So we have all of the actual messages are available here directly by just going and navigating to the correct step and looking at what's the result of this particular step in this particular integration execution context. And then we are doing a couple of things. So we're picking up the product ID and the product name out of the data that we are now returning for the consumer. And this is now a way for us to actually find and track the different sorts of executions we would be interested in, either from a metadata perspective. So if we were, let's say, interested in those executions that took the longest, we could order them by duration, or if we were interested in, for example, a more traditional process, which would be automating some sort of an information traveling between a web shop and different systems, we could utilize, for example, the customer ID now as something to show me all executions now for this specific customer ID from this and this date and time range. and then just dig down deep into the process itself to have an idea and look at what actually happened there when that integration flow was being executed. Now, of course, the same idea applies pretty much here, that now if I have my, let's say, subcomponent here to, for example, wrap another service or a system or an SQL server as an example, I could now see that, okay, this particular component is being used by these and these and these executions from these and these sources. And I could see that, okay, so for example, the durations and the execution intervals for system-specific calls. So the sub-processes approach is exactly the same information available, but when the processes view is from the main processes perspective, the sub-process is more from the system's perspective, access to the same underlying data that we have available there. And maybe lastly, now we're kind of running out of time. A quick look at the kind of governance things that we are doing here. So of course, the integration catalog of version control, automatic deployments, and all of that is part of the governance side of things. But and final piece of the puzzle that probably we haven't gone through is now limiting access to specific functionality here within Frends. So we are now, of course, utilizing SSO to log in users from our own HiQ domain, and of course for customers this could be their own single sign-on page or anything they might have chosen there. And now we are able to create what are basically simple roles for the user interface based on the different functions and attributes we want to allow each user to access. So we might create a role called user, where we might want to say that actually the viewer is someone who should be able to, first of all, view everything, but they should only be allowed to view things in development, and maybe in addition to allowing them to view things, they should be able to, let's say, run some of the instances or some of the solutions in the process or the development environment in this case. And I might say that, okay, Luke Dearden from the R&D team now there, he should be a viewer. So now when he logs in, he won't be even able to see anything else except the basic process view here. He won't have access to any of the buttons or anything like that. And the only button he will have access to is the run once button to test out maybe some things in the integration. All right, we are kind of getting to the end of our 2-hour session here. Thanks everyone so much for joining us, and hopefully this has been interesting and educational for you. We'll definitely do some more with some detailed focus on some special areas of the product, like focusing heavily on ETL related actions or data integration specific things, or more API focused stuff in the future. But this should have been and is a nice basic package on things to get started with the Frends development and understand how things are built and how to actually then create things yourselves and get them actually running and being integrations on their own. So we are now officially finished, and we will be now sharing this broadcast offline in a video link to all of you afterwards as well. So if you want to come back in and have a look at something at a later date, we'll definitely share that with you and hopefully have some additional value for you in that way. But if you have some questions or comments at this point, we will be staying on the line for 10 or 15 minutes here to answer some questions that you might have had during the presentation. But thank you everyone at this point and for participating, and hope to see you next time. Thank you.